Numerical solution of ordinary differential equation, Runge Kutta method. Runge Kutta fourth order method. So differential equation dy by dx is equal to f of x comma y with initial condition is given y of x0 is equal to y0, x0 comma x1 comma x2 be the equally spaced such that x1 minus x0 is equal to x2 minus x0 is equal to xn minus 1 is equal to h. So this x1 minus x0 it is denoted by h, so it is equally spaced x1 minus x0, so difference it is the same x2 minus x1, so on. This is denoted by h. Then first increment in y, that is y1 at x0 comma y0 is computed by using the formulas for the Runge Kutta fourth order method. Y1 is equal to y0 plus delta k, where delta k is equal to 1 upon 6 into the bracket k1 plus 2k2 plus 2k3 plus k4. Now within this we have to find k1, k2, k3 and k4. So formula is given below. K1 is equal to h into f of x0 comma y0. K2 is equal to h into f of x0 plus h upon 2 comma y0 plus k1 upon 2. K3 is equal to h into f of x0 plus h upon 2 comma y0 plus k2 upon 2. K4 is equal to h into f of x0 plus h comma y0 plus k3. Similarly, the second increment in y, that is y2 at x1 comma y1, where x1 is equal to x0 plus h. So this is the interval h. So x1 minus x0 is equal to h. Y1 is equal to y0 plus delta k. Then we have to find y2 is equal to y1 plus delta k, where delta k is equal to 1 upon 6 into the bracket k1 plus 2k2 plus 2k3 plus k4. Then we have to find k1. So formula for k1 is given like this: h into f of x1 comma y1. So we are finding the y2. We are finding the y2 at x1 y1. So here it is x1 y1. Then k2 is equal to h into f of x1 plus h by 2 comma y1 plus k1 by 2. K3 is equal to h into f of x1 plus h by 2 comma y1 plus k2 upon 2, bracket complete. K4 is equal to h into f of x1 plus h comma y1 plus k3. Now we'll see one example of this method. Apply Runge Kutta method to find y for x is equal to 0.2 in steps of 0.1. dy by dx is equal to x plus y square, given that y is equal to 1 when x is equal to 0. Now step number 1, we have to write the what is given from the example. So here it is, dy by dx is given. So dy by dx is equal to x plus y square is equal to, we have to write f of x comma y. So f of x comma y, it is x plus y square. This is given. Then given that y is equal to 1 when x is equal to 0, so you can write y is equal to 1, x is equal to 0. So this is y0 value it is given. So y0 is equal to 1 and x0 is equal to 0. Now we have to find y for x is equal to 0.2. So you can write here find y at x is equal to 0.2. Step it is given. So difference, or you can say interval it is given. So interval it is 0.1 it is given. So I can write here x0, then x1, then x2. Below x0 you can write y0. Below x1 you can write y1. Below x2 you can write y2. Value of x0 it is given. x0 it is 0. Step it is given. Step it is 0.1 it is given. So difference of x1 minus x0 it is 0.1. Again difference of x2 minus x1 it is a 0.1. Or you can say increment of 0.1. So first x0 it is given, this is 0. Then x1 it is first step, it is a 0.1. Then x2 it is 0.2. We have to find y for x is equal to 0.2. Within this, we have to find y1, it is for the point 1, so x1, and we have to find y2 at point 2, it is a x2. So for this example, we have to do two iterations. First one, it is to find the value of y1, then second it is we have to find the value for y2. Now first increment for y1 at x0 comma y0, y1 at 0 comma 1. So what is the value of x0? x0 it is 0 and y0 it is 1 and h it is given 0.1. So interval steps it is given 0.1. Now to write the formula, so y1 is equal to y0 plus delta k. Now delta k it is given like this, it is 1 upon 6 into the bracket k1 plus 2k2 plus 2k3 plus k4 bracket complete. Now step number 1, you have to find k1, then k2, k3, k4. So k1 formula it is h into f of x0 comma y0 is equal to. Now to find this function, how to find this function? See here, f of x comma y it is given x plus y square. So for this equation you can add a suffix here 0. So equation becomes f of x0 plus y0 bracket square into h. H it is 0.1, x0 it is a 0 plus y0 it is 1. So it is 1 square. So final answer it is a 0.1. Now to find the k2, so we have to write the formula for the k2. So k2 is equal to h into f of x0 plus h upon 2 comma y0 plus k1 upon 2 is equal to, so h value it is given 0.1, f of what is the x0? x0 it is a 0 plus h it is given, so it is 0.1 divided by 2 comma, here it is a comma, y0 it is given, y0 it is 1 plus k1, already we have found k1, so it is 0.1 divided by 2. Solve this. After solving we will get here 0.05 comma 1.05. Now here we get one function, see f of 0.05 comma 1.05. So equation it is f of x0 comma y0 is equal to x0 plus y0 bracket square. This is given, equation it is given. So below this you can take here x0 it is 0.05 plus y square, so it is 1.05 bracket square. Simplify this, multiplication with the 0.1, we'll get the answer here it is 0.1152. Then we have to find k3, so k3 is equal to h into f of into the bracket x0 plus h by 2 comma y0 plus k2 upon 2. We know the value of h it is a 0.1, f into the bracket value of x0 it is 0 plus h it is a 0.1 upon 2 comma y0 it is 1 plus this k2 value you can put here divided by 2. Simplify this, after simplifying we will get here f into 0.05 comma 1.0576. Now this is the function. Then these values you have to put in this equation. So in this equation it is given, so f of x0 comma y0 is equal to x0 plus y0 bracket square. So 0.1 into x0 it is 0.05 plus y0 it is 1.0576 bracket square. Solve this and multiply it with the 0.1, we will get answer here 0.1168. Then you have to find k4, so k4 is equal to h into f of x0 plus h comma y0 plus k3. H it is a 0.1, f of x0 it is a 0 plus h it is a 0.1 comma y0 it is 1 plus k3, this k3 value you can put here 0.1168. Now here 0 plus 0.1 it is a 0.1 comma 1 plus 0.1168 it is 1.1168. Now these two values you have to put in this equation, f of x0 comma y0 is equal to x0 plus y0 bracket square. So 0.1 into bracket 0.1 plus 1.1168 bracket square. After solving this, value of k4 it is 0.1347. Now all the values of k it is known, so you can find the delta k. So delta k is equal to 1 upon 6 into the bracket k1 plus 2k2 plus 2k3 plus k4. All the values of k1, k2, k3 and k4 you can put in this equation and final answer it is 0.1165. Now we have to find the y1. So y1 at point 1, formula it is y0 plus delta k. Y0 it is 1 and delta k it is 0.1165. So final answer it is 1.1165. This is the value of y1 at point 1. Now we have to find the second increment of y2 at x1 comma y1. So y2 at x1 it is 0.1 and y1 just we have found these values, it is 1.1165. Again we have to find the value of k1, k2, k3, k4. So k1 formula it is h into f of x1 comma y1 is equal to h it is a 0.1, f of x1 it is a 0.1 and y1 this is y1 1.1165. Now we have to write the equation of f of xy is equal to x plus y square. Suffix only you have to add here 1. So equation becomes f of x1 comma y1 is equal to x1 plus y1 square. So x1 it is 0.1 plus y1 square it is 1.1165 bracket square. Solve this multiplication with the 0.1. We will get the answer here 0.1346. Then we have to find k2. So k2 is equal to h into f of x1 plus h by 2 comma y1 plus k1 upon 2. H it is 0.1 given, f into bracket x1 it is a 0.1 plus h it is a 0.1 divided by 2 comma y1. So y1 it is 1.1165 plus k1, just we have found this value. So it is 0.1346 divided by 2. Simplify this. So we will get here 0.015. Again simplify this, we will get here 1.1838. So this is f of, so this is x1, this is y1. So f of x1 comma y1 is equal to x1 plus y1 bracket square. So you can write here 0.15 plus 1.1838 bracket square and multiplication with the 0.1. After solving, we will get the answer here k2 is equal to 0.1551. Then we have to find k3. So k3 is equal to h into f into the bracket x1 plus h by 2 comma y1 plus k2 upon 2. So h it is a 0.1. So f of 0.1 plus 0.1 divided by 2 comma y1 it is 1.1165 plus k2. So this is the k2 value. So 0.1551 divided by 2. Now you have to solve this. So this, after solving this, we will get here 0.15 comma, you have to solve this, we will get answer 1.19405. Now this is the function. So f of x1 comma y1 is equal to x1 plus y1 bracket square. So 0.15 plus 1.19405 bracket square multiplication with the 0.1, we will get the answer k3 is equal to 0.1575. Now we have to find the k4. So formula we have to write first. So k4 is equal to h into f of x1 plus h comma y1 plus k3. Value of h it is a 0.1, f of x1 it is 0.1 plus h it is a 0.1 comma y1 it is 1.1165 plus k3 it is 0.1575. So make addition here, so it is 0.2. Make addition here, it is 1.274. Now for this we can use the equation f of x1 comma y1 is equal to x1 plus y1 square. So x1 it is 0.2 and y1 it is 1.274. So 0.2 plus 1.274 bracket square multiplication with the h, value of h it is a 0.1. Final answer it is 0.1823. So this is the k4. Now to find the delta k, so all the values of k1, k2, k3 and k4 it is a known. So formula 1 upon 6 into the bracket k1 plus 2k2 plus 2k3 plus k4. So all the values you can put in this equation and find the value of delta k. So it is 0.1570. Now y2 at 0.2. So formula it is y1 plus delta k. So it is y1 it is a known as well as delta k it is known. You can put in this equation and y2 it is 1.2735 at 0.2. Thank you for watching video.